Example, find the extreme values of f of x equals 2x cubed minus 15x squared plus 24x plus 7 on the closed interval from 3 to 6. We'll apply the extreme values on a closed interval theorem and follow the suggested 4-step procedure. The first step is to find any critical points. To find critical points, we must begin by determining the domain of the function. Our function is a polynomial. A polynomial's domain is the set of real numbers. No variables in the denominator, no powers to an even root. The next step is to find the derivative. Remember, we need to set this derivative equal to 0. So the derivative of 2x cubed will be 6x squared. The derivative of negative 15x squared is negative 30x. The derivative of 24x is 24. The derivative of 7, since 7 is a constant, is 0. Now we're going to solve for where the derivative equals 0. There are no places where the derivative would be undefined. So we have 0 is equal to, factor out a 6 that's common to those three terms, 6 times x squared minus 5x plus 4. Now we'll factor that quadratic. 0 equals 6. And factoring, we'll have x minus, the factors of 4 that work would be 1 and 4. Now we can list the critical values. Our critical values occur at x equals 1 and x equals 4. The next step in the procedure is to compute the value of f at these points. So we'll compute at these points. What I like to make note of is that one of the points, x equals 1. 1 is not in the interval from 3 to 6, so we don't need to compute that. That's not in the domain we're considering. 4 is in the interval between 3 and 6, so we do need to evaluate the function at 4. F at 4 is 2 times 4 cubed minus 15 times 4 squared plus 24 times 4 plus 7, and that is equal to negative 9. The third step says compute at the endpoints of the closed domain. And so we need to compute f of 3 and f of 6. So f of 3 will have 2 times 3 cubed minus 15 times 3 squared plus 24 times 3 plus 7. That equals negative 2. Let's do this again for f at 6. 2 times 6 cubed minus 15 times 6 squared plus 24 times 6 plus 7 is equal to 43. And step 4 of the procedure says that the absolute maximum is the largest values found in the previous steps and the absolute minimum is the smallest value found in the previous steps. And the fourth step of the procedure says that the absolute maximum is the largest value found in the previous two steps, and the absolute minimum is the smallest function value found in the previous two steps. So we have an absolute max at 6, whose value is 43, and we have an absolute minimum at 4, whose function value is -9.